Hello, welcome you all again in the series of analog communication systems. In previous lectures, we have talked about basically the amplitude modulation, the angle modulation, in which we have completed two categories. One is the frequency modulation and another one is the phase modulation. Once we have completed this one, in which the carrier is basically a sinusoidal wave, we are moving ahead to the next section, which is the pulse modulation. The pulse modulation is basically consisting, this time we have carrier as a pulse instead of having this carrier as a sinusoidal wave. So that is going to make a change in our modulation system, and we are going to have a study here. So let's get a brief idea of this pulse modulation. So first of all, we divide this pulse modulation into the two categories. First is called as an analog pulse modulation and second is called as a digital pulse modulation. The analog pulse modulation can be further divided into the three categories: pulse amplitude modulation, pulse width modulation, pulse position modulation. And while we are talking about the digital pulse modulation, we can divide into the two categories, which is the pulse code modulation and the delta modulation. So, well, as we were talking about basically the continuous wave, that was basically the sinusoidal wave, and this time we are having the pulse wave. So try to find out the difference between these two. Transmitted power is no longer continuous as in continuous wave modulation, but pulsed in nature. This is a very crucial point. As what happens during the continuous wave, we are transmitting a power, we are having a power, and the carrier wave we are transmitting from one place to another place. So what happens during this point, every time power is being consisted by the carrier wave. But in the case of the pulse modulation, we are getting this as a point of an advantage, that transmitted power is no longer continuous as in continuous wave modulation, but pulsed in nature. So by this we can easily save the power. This is a basic process by which we can save the power. Waiting time between the pulse occurrence filled by the interleaving multiplexing pulse waveform some other message TDM. Other thing is here, like suppose we are transferring the continuous, the bandwidth required for the channel is definitely higher one. So in such a case, what we are doing, we are using here the pulse, and then pulse is helping to transmit with less requirement of the bandwidth. It means the space during the pulses we can use for the multiplexing. It means the filled by the interleaving multiplexing pulse waveform for some other message stadium. So on the same channel, the multiplexing can be occurred, the multiplexing can be done, and this multiplexing will help to utilize the channel in a better way. So as first we are going for this pulse code modulation, the first of all theory comes, which is called as a sampling. We have to understand the sampling process. You know what happens, we have a continuous wave. That continuous wave has to be converted into the form of a pulse. The process of this continuous wave to be converted into a pulse is called as a sampling, a very simplest process. Let's understand by the definition. This provides a mechanism of representing a continuous time signal by a discrete time signal. So we are talking about a simple sinusoidal wave, we have already talked about, is a continuous time wave, और second is called basically a discrete time signal. Simply अगर हम बात करें यहाँ पर for a clarity, for a clarification, हम लोगों ने कैरियर वेव यूज़ किया था पिछली बार. इस कैरियर वेव में कंटिन्यूस वेव था. कंटिन्यूस वेव का मतलब एक साइनसॉइडल वेव था जो कंटिन्यूसली हमारे मैसेज सिग्नल को कैरी करता था अपने साथ. इस बार हम उस कैरियर सिग्नल की जगह क्या यूज़ कर रहे हैं, पल्स यूज़ कर रहे हैं. ये पल्स जो है वो पल्स अब हमारे लिए एक एडवांटेज लेके आई है. एडवांटेज क्या है कि इस बार हमें जो पावर है, पावर सेव कर सकते हैं, क्योंकि ऑल द टाइम द पल्स इज नॉट प्रेजेंट. जितनी देर में वो पल्स होगी द पावर इज कंसिस्टेंट ओनली ड्यूरिंग द पल्स पीरियड. बहुत बड़ा बेनिफिट हमें ये भी मिलता है कि अब अगर हम पल्स को यूज़ करें तो पल्स प्रोवाइडिंग ए स्पेस ऑन चैनल, पल्स चैनल के ऊपर स्पेस प्रोवाइड कर रही है. और ये जो चैनल के ऊपर स्पेस प्रोवाइड किया जा रहा है, इस स्पेस की वजह से आपको बेनिफिट ये मिलता है कि आप बाकी सिग्नल्स को, दूसरे सिग्नल जो सेम चैनल के ऊपर है, उन सिग्नल्स को भी इसके ऊपर मल्टीप्लेक्स कर सकते हो. सो दिस इंटरलीविंग मल्टीप्लेक्सिंग प्रोसेस इज टू गुड. तो हम यहाँ पे बात करें अब इसके लिए करने के लिए प्रोसेस क्या होता है. सबसे पहले ज़रूरी होती है सैम्पलिंग प्रोसेस को समझना. तो किसी भी कंटिन्यूस टाइम सिग्नल को जब डिस्क्रीट टाइम सिग्नल में कन्वर्ट किया जाता है, देन इट इज कॉल्ड एज अ सैम्पल. Let's see here by definition. This provides a mechanism for representing a continuous time signal by a discrete time signal, taking sufficient number of samples of signals so that the original signal is represented in samples correctly. It can be stated as. सीधी सी बात है. If a shape is here, suppose that this hand is here, this hand has certain envelope. So rather than using the complete surface of this hand, it is better we can use some dots points so that on the behalf of these sample and dots one can create. तो पूरा हाथ ना लीजिए, पूरा हाथ ना लेने की जगह आप क्या कीजिए, इस पर डॉट्स ले लीजिए. ये डॉट्स आपको भी क्लियर करेंगे ना कि आपका पूरा हैंड का एनवलप है. दिस इज व्हाट द सैंपल. सो वी हैव जस्ट टेकन अ सैंपल एंड सैंपल हैज टू बी टेकन बाय सच केयर कि व्हेनेवर वी आर गोइंग फॉर रिट्रीविंग, सिग्नल को दोबारा से रिट्रीव करना है, तब हमारे पास से इसका एनवलप कंप्लीट होना चाहिए. सफिशिएंट नंबर ऑफ सैंपल्स होने चाहिए जिससे कोई भी शेप का पार्ट, कोई भी सिग्नल का पार्ट गायब ना हो, मिस ना हो जाए. सो वी हैव अ सैम्पलिंग थ्योरम हियर. It states a band limited signal of finite energy with no frequency component higher than FM Hertz is basically the unit is completely derived by sample values which are uniformly intervals less than or equal to 1 by 2 FM second parts and TS equals to 1 by 2 FM where TS is the sampling time. Sampling frequency must be equal to or higher than 2 FM Hertz. So what they are saying suppose that अगर हमारे पास कोई सैंपल है जिसका कि हमें बेसिकली सैम्पलिंग करना है, तो उसकी फ्रीक्वेंसी अगर हम एफएम की बात करते हैं, नॉट शुड बी एफएम, एफएम हमने ले लिया कंसिडरेशन. अब ये जो एफएम है और अगर इसके में सैंपल्स क्रिएट करने जाते हैं तो सैम्पलिंग फ्रीक्वेंसी मस्ट बी इक्वल और हायर देन 2 एफएम. मतलब जो भी नेचुरल फ्रीक्वेंसी होगी हमारे सिग्नल की, उसके अपीयरेंस की, तो सैम्पलिंग हमेशा उससे डबल फ्रीक्वेंसी पे की जाएगी. Then only it can be retrieved. So this is a very important theorem. Number of times it is also called as an IQ's criteria. So number of times the sampling theorem is being fs is greater than equals to twice of fm. या तो बराबर होगी क्रिटिकल के लिए या उससे ज़्यादा होनी चाहिए. Continuous time signal may be completely represented in samples and recovered back if fs is greater than equals to twice of fm and fs is sampling frequency and fm is the maximum frequency component of the मैसेज सिग्नल. तो fs आपकी सैम्पलिंग फ्रीक्वेंसी हो जाती है, fm आपकी मैक्सिमम फ्रीक्वेंसी ऑफ द कंपोनेंट. फिर सपोज और नंबर ऑफ फ्रीक्वेंसीज हैं, उन नंबर ऑफ फ्रीक्वेंसीज के बीच में जो मैक्सिमम फ्रीक्वेंसी कंपोनेंट होगा उसका ट्वाइस होगी सैम्पलिंग फ्रीक्वेंसी. देन इट विल वर्क ऑनली. Let's we have a little discussion of proof. How we can prove it? So before going to have a proof, let's understand what we are doing in a sampling. Suppose that we have this continuous wave signal. And this continuous wave signal is to be multiplied or converted with the impulse train. A very simple process. आपके पास में एक सिंपल ही continuous wave है. इस continuous wave को आप impulse train के साथ, impulse train का मतलब a signal which is defined only at a point, not here and there. It means delta t is an impulse function and this delta t function has its value 1 only at t equals to 0. And we are looking for second. Then this should be delta t minus ts. It is defined as a ts and having the value of 1. Similarly for the positive, so we have a sequence of train. So that has been taken care here. Let's say we have a sampling. Input signal is xt. Xt is to be taken up here. Second is to be taken as the impulse train, which is the delta t. Impulse train, it's a sequences of the impulse. Multiple combination of the impulse are here. That has been taken here. Third, now we have a convolution and multiplication of this yt equals to xt into delta t. The Fourier series representation of this delta t is given here. How we can represent it? It's okay, it's not a big deal. So on multiplying this, what happens? Where this has a magnitude as 1, that will be multiplied here and rest of the part will be taken up to 0. So this impulse train will acquire exactly the instantaneous amplitude of this xt signal like this. इस इम्पल्स ट्रेन ने क्या किया, ये खुद किसका एम्पलीट्यूड 1 था, जिस एम्पलीट्यूड से मल्टीप्लाई हुआ वही एम्पलीट्यूड इसने एक्वायर कर लिया. अब उसने वही एम्पलीट्यूड एक्वायर किया तो इट इज गेटिंग अ एग्जैक्ट एनवलप, वही शेप इसने लिया. दिस इज व्हाट द इम्पल्स ट्रेन. द सेम इज गिवन हियर इन द मैथमेटिकल रिलेशनशिप. एंड फाइनली on multiplication, if you want to do that, it's a very simple process. Use this all, find out all impulse trains and getting all these values that are different values in interval time. Then we are getting yt equals to xt delta t, multiplying with this train, and finally we are getting this mathematical expression. So the later on we can understand about a mathematical expression that can be submitted on your request. It's a simple process. So y omega, if somebody is looking for find out the value of frequency domain response, this frequency domain response can be represented as y omega equals to 1 upon ts n summation minus infinity to plus infinity x omega minus n omega s. So looking back to this here, so this is basically your signal xt. Here we have the impulse train. When we are multiplying this, it will become like that. If this xt has a frequency domain response, this x omega, it means from certain frequency minus omega m to plus omega m, and then we are looking for this impulse train, that this will be having that kind of a response, frequency response at the different interval of the frequencies, starting from minus omega s, because it was started from the minus ts, so minus omega is shifted, minus 2 omega is shifting, minus 3 omega s will be shifting. Similarly on the positive side, ts, 2ts and so on, these will be shifted. So this kind of a number of the shifted amplitude or frequency response analysis will be getting. Now coming on back. So as we have already talked about, basically this is the delta t. Delta t can be represented as like this. Now as we know that we have the Fourier series expansion, we can find out the value of this a naught, an, bn and so on. So getting all we can find out a naught, simply an and bn. These are all basically by the definition. We know that the definition from the Fourier series, one can have this a naught equals to 1 upon ts minus t by 2 delta t dt. ये by definition से जब आप Fourier series expansion करते हैं किसी भी फंक्शन का, तो Fourier series expansion में आपको एक constant टर्म होता है, कोसाइन टर्म होता है, इवन टर्म होता है और ऑड टर्म होता है. इवन टर्म कोएफिशिएंट्स होते हैं, ऑड टर्म कोएफिशिएंट्स होते हैं, एंड दीज आर द स्टैंडर्ड रिलेशनशिप ऑफ इवन एंड ऑड टर्म कोएफिशिएंट्स. तो जब आप ए एन बी एन इन सब के वैल्यूज को फाइंड आउट कर लेते हैं, तो इट इज टू बी क्लियर फॉर द लेटर ऑन गोइंग टू द फ्रीक्वेंसीज, दिस कम्स ऑन द रेट ऑफ चेंज बिकम्स द वैल्यू ऑफ 0. Coming on a point. So this delta t equals to 1 upon ts 2 by t cos n. It means we are finding all the odd parts we are receiving as 0. So delta t equals to 1 upon ts and equals to 1 to infinity 2 by ts cos n omega s t plus 0. Substitute here. Then after substituting we are getting xt. Xt is being multiplied, and what we have the value xt, that will be multiplied in each and every term. Xt alone, then this xt, then this xt is multiplied with the 2 omega s, then is multiplied with 3 omega s and so on. And while we are taking the Fourier transformation of this one, so this will becomes xt 1 upon ts x omega xt. We know that xt का हम frequency domain analysis लेते हैं तो क्या आता है, x omega आता है. cos omega s होगा तो x omega minus omega s आएगा. इसके दो कंपोनेंट क्रिएट होते हैं, ओमेगा माइनस ओमेगा एस प्लस ओमेगा प्लस ओमेगा एस. सो दीज टू टर्म्स विल बी देयर. सिमिलरली फॉर माइनस में अल्टीमेटली इस एक्सप्रेशन का टारगेट ये है कि आपको ये समझाना कि किस तरीके से जब आप फ्रीक्वेंसी डोमेन एनालिसिस को लेते हैं तो उसके लिए मैथमेटिकल एक्सप्रेशन निकाला आपने. मैथमेटिकल एक्सप्रेशन किसका लिए, इम्पल्स ट्रेन का लिया. इम्पल्स ट्रेन का एक्सपेंशन चेक किया. वो एक्सपेंशन किससे आया, फोरियर सीरीज से आया. फोरियर सीरीज ने एक्सपेंशन दिया. एक्सपेंशन के बाद वह सारे के सारे इवन पार्ट्स रख लिए, ऑड पार्ट्स हटा दिए. इवन पार्ट्स रखने के बाद में देखा कि जब हम उसको मल्टीप्लाई करते हैं एक्सटी से तो एक्सटी ओमेगा एस 2 ओमेगा एस 3 ओमेगा एस फ्रीक्वेंसी कंपोनेंट के साथ मल्टीप्लाई होता है. और जब इसकी फ्रीक्वेंसी डोमेन एनालिसिस करते हैं तो ये वही एक्स प्लस ओमेगा एस एक्स माइनस ओमेगा एस की कंपोनेंट क्रिएट करेगा, प्लस 2 ओमेगा एस माइनस 2 ओमेगा एस प्लस 3 ओमेगा एस माइनस 3 ओमेगा एस ये कंपोनेंट्स क्रिएट करेगा. और इसी के हिसाब से हमारा फ्रीक्वेंसी स्पेक्ट्रम बन जाएगा. So similarly we are getting this response. Important factor, Aliasing phenomena. जब हम किसी भी सैंपल को रिट्रीव करते हैं, अब हमने सैंपल्स में क्रिएट कर दिया, जब हम इन सैंपल्स को रिट्रीव करते हैं then we require basically this Aliasing effect. So overlap region in the case of undersampling, suppose that here we have this basically frequency domain analysis in which this is the first sample, second sample, third sample, fourth sample, and all the samples are distant apart. This is the perfect sampling in which there is no distance. It means the first sample exactly connected with the second sample, third and so on. And third case is what? The samples are overlapped on each other. So the first case is called as fs is greater than 2fm. fs equals to 2m times perfect sampling, and fs less than what happens? जो हमने initial condition की बात करी थी कि ये होना चाहिए, then what happens? Undersampling. So this undersampling creates the Aliasing effect, and Aliasing effect tells you the samples cannot be recovered. Represents Aliasing effect. It can be termed as the phenomenon of high frequency component in the spectrum signal taking on the identity of the lower frequency component in the spectrum of the sample version. The frequency components match हो गए और retrieve करने में ये प्रॉब्लम की बात है. So we should avoid and we should follow the Nyquist rate and Nyquist criteria for the sampling. I hope so. This is a short video. You must be able to understand basically what is the pulse modulation scheme, how we can distinguish them. Second, you would be able to understand the sampling process, its frequency domain response, as well as what happens if suppose the Nyquist rates and Nyquist criteria is not being followed. So all these conditions are important. Hope so you have gotten the most of the idea relating with this. The next video will be shared with you soon regarding the next and for more information about the pulse modulation. Till there, if you have another doubt, if you have any concern, any query related to anything, you can drop your message. Thank you very much.